This video is part 3 of our review of the first semester of geometry. In this video, we will review right triangle trigonometry. So we will be using tangent, sine, and cosine to find missing sides and missing angles. Anyway, number 14, find the side length marked x. So, it's all about Sohcahtoa. You have to remember that if you are dealing with a right triangle, if you pick a particular angle to look at, across from that angle will be called the opposite side, the opposite leg. Well, first of all, every right triangle has a hypotenuse. That's across from the 90-degree angle. So this is the hypotenuse. Now, other than the hypotenuse, if we look across from the angle, that's called opposite. Right next to the angle, that's called adjacent. So sine, cosine, and tangent are defined like this. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. By using this funny word Sohcahtoa, we can remember these three definitions. The sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and toa, tangent, is opposite over adjacent. So that's what we have to do. When I look at this, you know what, let me zoom in. Start by identifying the hypotenuse. Here's the 90-degree angle. That makes this the hypotenuse. Alright, now decide what angle you're going to focus on. Across from the angle is always going to be the opposite leg. Right next to the angle is going to be the adjacent leg. Okay, now consider Sohcahtoa. Let's see, which one of these three sides is doing nothing? The hypotenuse. We're not given the value, and it's not what we're looking for. The hypotenuse is useless. So that means we're not going to use the sine function. We're not going to use cosine. Both of those have the h in it. They have the hypotenuse that we're not using. So that tells us that we're going to use tangent. So remember, tangent equals opposite over adjacent. So remember, you do tangent and then you put the angle. So tangent of 61 is equal to opposite over adjacent. Now there are three types of equations. If the variable is in the top, that's when you multiply. So what you want to do is you will solve this by multiplying both sides by 40. That way these cancel out and that leaves x by itself. And then this can just go straight in the calculator. And you can just type it the way it looks, except you don't even need the parentheses. You can just write 40 tangent 61. Alright? Use 3 decimal places unless they say otherwise. So that's 72.162. Got to round up. Alright, did I say that right? 72.162. Okay, so that's it. That is the length of the side marked x. Let's do the same thing again, maybe a little bit faster. So start with the hypotenuse, which is right here across from the 90-degree angle. Pick an angle to focus on. Of course, we'll choose the 44, only angle we have. Opposite from the angle, you know, is going to be, well, the opposite leg. Right next to the angle is called the adjacent leg. Consider Sohcahtoa. Which one of these is doing nothing? The opposite leg is totally empty. So see how that has an O in it? Goodbye. See how there's an opposite right there? Goodbye. We're doing cosine. So cosine is adjacent over hypotenuse. So we write cosine of the angle, so cosine 44, don't leave off the 44, is equal to adjacent, which is 17, over the hypotenuse, which is x. Okay, so this is similar to the last equation. But when the variable is in the top, that's when you multiply. When the variable is in the denominator, this is when you swap these. All right, I'm just going to take these two things and I'm going to reverse them. All right, not just the 44, but I will swap x and cosine 44. So this is going to give me x is equal to 17 over cosine 44. Okay, so I can do 17 over cosine 44. 23.633. Got to round up. 23.633. Number 16. A 45-foot long cable connects the top of a 30-foot tall tower to a stake in the ground. Alright, we better draw a picture of that. So here's the ground. Here's a tower. Here's a stake in the ground. And here's the cable. Okay, now what? Let's see. It's a 40-foot long cable, so that means that this is going to be 40 feet long. Alright, this tower is presumably straight up and down, so that's a right angle. Let's see, the top of a 30-foot tall tower. So that means this is 30 feet. Okay, what angle is formed by the cable and the ground? Here's the cable, here's the ground, so we're talking about this angle right here. Okay, so we have to find that x. We're going to do the same thing we did before as far as setting this up. Start with the hypotenuse, which is across from the 90-degree angle. So this right here is the hypotenuse. Okay, next, you pick an angle to look at. Of course, I'm going to pick this angle because that's the angle that I'm looking for. Across from the angle is the opposite leg, and right next to the angle is the adjacent leg. Now, which one of these sides is not doing anything? Well, I forgot to write down Sohcahtoa. Sohcahtoa. Which one of these sides is not doing anything? The adjacent side. We're not given it and we're not looking for it. So see that A that stands for adjacent? Peace out. See that A that stands for adjacent? No good. So that means we're going to be using the sine function. Sine is opposite over hypotenuse. So that means sine of the angle. Alright? The angle goes here even though it's unknown. Sine of the angle is equal to opposite over hypotenuse. So that's 30 feet over 40 feet. Okay, so this is the third type of equation. Alright, can I scroll back real quick? When the variable is in the top, we multiply. When the variable is in the bottom, you swap. Okay, now when the variable is inside the trig function, this is when you do the inverse. So you go like this. X is equal to the inverse sine, that's what the little -1 means, inverse sine of 30 over 40. Okay, that's what you do when the variable is inside the trig function. And this is something you can just put in your calculator. Let me show you how. We want the inverse sine, so we do second sine of 30 over 40. So 30 over 40. And that gives us the angle, 48.59, well, 0. . Alright, 48.590 degrees. That's the angle between the wire and the ground. A ladder leans against a vertical wall. The ladder is 18 feet long and there's an 11-degree angle formed where the ladder meets the wall. Okay, let's see. Here's the ground. Here's the wall. Okay, and here is the ladder. Leaning up against the wall. Okay, so of course this is a right angle. Now what? The ladder is 18 feet long, so this is 18 feet. There's an 11-degree angle formed where the ladder meets the wall. So this is 11 degrees right there. Ladder, wall. What is the distance between the wall and the base of the ladder? So the base of the ladder is here, the wall is here, so we are looking for this distance right here. Let's start by indicating the hypotenuse, which is always across from the 90-degree angle. So that means this is the hypotenuse. Okay, now next we circle the angle that we're going to look at, and this is the only angle we got. Across from the angle will be the opposite leg. So that means this is the opposite leg. Right next to the angle is called the adjacent leg. So this right here is the adjacent leg. Which one of these? Well, first we write down Sohcahtoa. Sohcahtoa. Alright, which one of these sides is not doing anything? The adjacent. There's no number given here and we're not being asked to find it. So, because adjacent is useless, I need to throw out this function because it involves adjacent. I need to throw out this function for the same reason. So that means we're going to be doing the sine function. So sine is opposite over hypotenuse. So I will write the sine of the angle, so sine of 11, is equal to opposite over hypotenuse. Alright, we're back to that first example that we did where the variable is in the numerator. When the variable is in the numerator, that is when you multiply. So I'm just going to multiply both sides by 18. That gets x by itself. And then you just put this in your calculator. Okay, you go 18 sine 11. So that is 3.435. Got to round up. And these are feet. Okay, so that's the distance from the base of the ladder to the wall. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.